Welcome to Network Professionals. Hello everyone. Welcome back to our channel Network Professionals. I'm engineer Javiria Oftab, CISCO certified instructor. In the last lecture, we discussed chapter 5. In this lecture, we will resume from where we left off in the previous topic. Internet connection types. Line of sight wireless internet service. Line of sight, LoS, wireless internet is an always-on technology that uses radio frequency signals to establish a connection between two fixed points, usually a transmitter, like a tower, and a receiver, such as an antenna on a building. For this connection to work effectively, there must be a clear, unobstructed path between the 2 points. This is what we call the line of sight. This type of service is commonly used in rural or remote areas where wired connections like DSL or fiber are not available. However, its performance can be affected by weather conditions such as rain, fog, or heavy winds, which can weaken the signal strength and reduce internet speed. Despite this, LoS wireless internet can provide high-speed internet where other options are limited. Internet connection types. Satellite. Satellite internet is a broadband solution designed mainly for remote or rural areas where other internet options are limited or unavailable. It uses a satellite dish to send and receive data to and from satellites orbiting Earth. However, it is not ideal for time-sensitive tasks such as online gaming, VoIP calls, or video conferencing due to higher latency. A newer option is low Earth orbit, LEO, satellite internet, which involves many satellites orbiting closer to Earth. Offers speeds of up to 100 megabits per second. Has much lower latency, 100–200 milliseconds, making it better for more real-time applications compared to traditional satellite internet. Internet connection types. Cellular. Cellular internet uses cell towers to provide wireless internet access, commonly used by mobile phones and other wireless devices. It allows users to connect to the internet while on the move, using technologies like 4G, 5G, and LTE. Cellular internet is convenient for mobile browsing, streaming, and hotspot sharing, especially in areas where wired connections are unavailable. Internet connection types. Mobile hotspot and tethering. Mobile hotspot and tethering are features that let a cell phone share its internet connection with other devices. This can be done using Wi-Fi, Bluetooth, or a USB cable. The connected device uses the phone's cellular data to access the internet. When the phone creates a Wi-Fi network for other devices, it's called a * mobile hotspot. This is useful for providing internet on the go when no Wi-Fi or wired connection is available. In the second topic, we will discuss networking protocols, standards, and services. Transport layer protocols, the TCP or IP model. The transport layer of the TCP or IP model is responsible for providing reliable or unreliable delivery of data between devices across a network. It ensures that data is transferred correctly and efficiently from source to destination. There are two main transport layer protocols. First, TCP, Transmission Control Protocol. Connection-oriented protocol ensures reliable delivery of data by establishing a connection before data is transferred. Data is sent in segments, and each segment is acknowledged. If a segment is lost, TCP retransmits it. Used in applications like web browsing, HTTP, HTTPS, email, SMTP, and file transfers, FTP. Second, UDP, User Datagram Protocol. Connectionless protocol provides unreliable but faster delivery of data. No acknowledgements or retransmissions. Used in applications where speed is important, such as video streaming, online gaming, and VoIP. In the TCP or IP model, the transport layer plays a vital role in managing how data moves between applications on different devices, ensuring smooth communication across the network. Transport layer protocols. TCP, Transmission Control Protocol, a connection-oriented protocol that ensures reliable data transmission. Three basic operations of TCP reliability. First, numbering and tracking. TCP assigns sequence numbers to data segments to keep track of their order. Second, acknowledgement. The receiver sends an acknowledgement, ACK, for each received segment to confirm successful delivery. Third, retransmission. If the sender doesn't receive an acknowledgement in time, it retransmits the data to ensure delivery. These operations ensure that data is delivered accurately and in the correct order. Transport layer protocols. UDP, User Datagram Protocol, a connectionless protocol with low overhead. Key features of UDP. First, very little overhead, minimal error checking and no flow control. Second, best effort delivery. No guarantee of delivery, order, or duplication protection. Third, no acknowledgement. The receiver does not send back any confirmation of data receipt. UDP is fast but unreliable, used where speed is more important than reliability, e.g., video streaming, online gaming. Classification focusing on worldwide protocols, email and identity protocols, and remote access protocols. Application port numbers. Application port numbers are numerical identifiers that help direct internet traffic to specific services or applications on a network device. They ensure proper communication between client and server. Classification of application port numbers. First, worldwide protocols, used globally for web and file services. HTTP, port 80, web browsing. HTTPS, port 443, secure web browsing. FTP, port 21, file transfer. DNS, port 53, domain name resolution. Second, email and identity protocols, used for sending, receiving emails and managing user identity. SMTP, port 25, send emails. IMAP, port 143, receive emails. POP3, port 110, download emails. LDAP, port 389, directory services, user identity. Third, remote access protocols, used to control or access devices remotely. SSH, port 22, secure remote login. Telnet, port 23, remote access, less secure. RDP, port 3389, remote desktop for Windows. Network operations protocols, used for monitoring, managing, and diagnosing network performance. SNMP, port 161, network management. ICMP, no port, used for ping, traceroute, syslog. Port 514, system logging. NTP, port 123, time synchronization, file transport and management protocols. Enable file sharing, access, and management over a network. FTP, port 21, file transfer protocol. TFTP, port 69, trivial file transfer protocol. SFTP, port 22, secure FTP over SSH. SMB, port 445, file sharing in Windows. Wireless protocols. WLAN protocols, Wi-Fi standards. WLAN, Wireless Local Area Network, protocols are based on IEEE 802.11 standards, which define how devices connect and communicate over Wi-Fi. Here are some comparison of IEEE 802.11 Wi-Fi standards. Wireless protocols, Bluetooth, NFC, and RFID. Wireless protocols allow devices to communicate without physical cables using radio waves. Here are 3 common wireless communication methods used for short-range data exchange. Bluetooth. Purpose: used for short-range communication between devices like phones, headsets, speakers, and laptops. Standard: based on IEEE 802.15.1. Range: typically up to 10 meters. PAN, Personal Area Network, can connect up to 7 devices at once. Frequency range: operates between 2.4 GHz to 2.485 GHz. Use cases: file sharing, wireless keyboards, mice, headphones, smartwatches, etc. RFID, radio frequency identification. Purpose: used to identify and track objects using tags and readers. Types: passive RFID, has no battery. The RFID reader activates the tag and reads its data. Active RFID, contains a battery and broadcasts signals up to 100 meters. Frequency range: operates between 125 MHz to 960 MHz depending on the system. Use cases: inventory tracking, ID cards, pet microchips, supply chain management. NFC, near-field communication. Purpose: used for very short-range communication between devices. Proximity: devices must be within a few centimeters of each other. Technology base: a specialized form of RFID. Use cases: contactless payments, e.g., Google Pay, Apple Pay. Smart posters, quick pairing. Public transportation and parking systems. Secure data transfer, e.g., sharing contacts or files instantly. Wireless protocols: Zigbee and Z-Wave. Zigbee and Z-Wave are wireless communication protocols mainly used in home automation and IoT, Internet of Things. They are designed for low power, short-range communication between smart devices like lights, sensors, thermostats, and door locks. Zigbee, standard, based on IEEE 802.15.4. Network type, uses a wireless mesh network, where each device can pass data to the next, increasing the range. Coordinator required. A Zigbee coordinator, like a hub, is needed to manage the network and connected devices. Frequency range, 868 MHz to 2.4 GHz, commonly 2.4 GHz. Range, up to 20 meters indoors, can increase with mesh. Device capacity, supports up to 65,000 plus devices. Speed, up to 250 kilobits per second. Control, devices are often managed using mobile apps or smart home assistants. Use cases, smart lights, thermostats, sensors, door locks, etc. Z-Wave, standard, proprietary protocol, developed by Z-Wave Alliance, but a public version is available. Network type, also uses a mesh network. Device capacity, supports up to 232 devices per network. Frequency range, operates around 800 to 900 MHz, depends on region. Speed, up to 100 kilobits per second. Range, typically 30 to 100 meters, better wall penetration than Zigbee due to lower frequency. Use cases, home automation, lights, locks, alarms, sensors. We'll discuss the remaining topics in the next lecture. Thanks for watching. Subscribe our channel Network Professionals for more informative videos.